Okay, those first three on there, you were just asked to graph. You ought to be able to type something like those into your calculator and get an alright picture of them. I won't be able to get a real good one on here, but I did graph them, and I do have something that looks similar to them. My first one, that's the little piece they gave me there. It goes through the point 0, 1, and it's just to the left of the y-axis and levels out on the x-axis, something similar to that. Okay, check your calculator if you need to. On my second one, what? I got through the point 1, 0. I come up to the y-axis, and I go just below the x-axis, something similar to that. I had a point at 5, -1 over here too. So I'd see I did go to my table and get a couple of points when I could to help me draw them on there. Then on my last one, on number 3, it went through the point 0, 2, crossed over there and just barely went to the x-axis, something like that. Y'all able to graph those pretty good in your calculator?
Barely.
The calculator doesn't really show them extending a whole lot. It kind of looks like they just go somewhere and stop, but they do keep extending. It's kind of hard to read in those. Yeah, kind of hard to read in those low resolution stuff. All right, 4 through 8. Now, I did all those in my calculator also, and I did not follow the directions when I did 4 through 8. Okay, look, I don't even know if you looked at the directions. It tells you some approximates to use and to solve it that way. But like on number 4, I just went to math log base and typed that in. Okay, now what I would warn you is look up there at the directions and see how many decimal points they rounded to. That's what you need to round to. Whatever you're given is how far you need to go. So in that in those directions up there, they got tenths, hundredths, thousandths, 10,000ths. 1, 2, 3, 4 numbers after the decimal. So your answers need to go 4 numbers after the decimal also. So you might need to make you a note on that. We'll run. That's okay. I mean, that's why we're going over it. But you note that for the test. So on number 4, I got 2.8907. Okay, so you might need to add a few more digits to round it where they did.
I had most of them, except for those last 2 points.
We have to do that?
Yeah, that's what I just said, yeah. If they give you a digit that they rounded to, that's your rule for rounding also. So they've got 4 after the decimal, we're getting 4 after the decimal. Number 5, I got 0.5688. Now, other than the rounding part, if you're completely off, we need to know so I can help you type it in your calculator right. I mean, I get it if you didn't round exactly right, but if you don't have 0.56 or 57 on this one, we need to know so we can help you. We good? Okay, on number 6, I got 3.4594. They are right there. Now 7 and 8, you got to do a little bit more work on those because they had multiple parts. So be careful typing those in your calculator. On number 7, I got 2.7297. Did you get something close to that? Good, good, good. And then on 8, I got 1.1610. Okay, so as long as you round correctly, so far on 1 through 8, everybody's making 100. I mean, there's no reason for anybody not to get any of that right. Okay, 9 through 12 now is where we got to do the transformations, and it's got 2 answers on all those, so make sure you do both answers. Don't miss points because you don't. It says describe it and then write the rule. That means write the equation, so we got to do both things. So what I did on number 9 is I first off went to my graphing calculator and I just graphed y equals log of x to see what it looks like. What I found was that when I graphed that, it had a point at 1, 0. So it had a point right there, and then I compared that to the graph that they gave me. The graph they gave me, the point was up there. So I counted and saw that it scooted it up 1. So I graphed y equals log x and went and looked at my table.
How do you do log x?
Hit log on the far left next to the 7 button and then an X. Are you in the graph yet? Y equals. Okay, so that's how you'll do all four of those. You'll graph the equation they gave you, find some points, and then compare that to the picture of the graph. So I've done that. I've decided it's scooted up one, so my two blanks over there for number 9. Oh, hold on. I'm on a different problem. Screwing that up. I did have the point at 1, 0. That's right. Now look at the graph, though. When I graphed y equals log x, that point at 1, yeah, you're right. That point at 1, 0, it was like that, right? And then the graph they gave me is over here, isn't it? So it's scooted, yeah, so it's scooted at left is what we're looking at. So we had to count and see how many it scooted at left. So I said g of x,
1.
good, Landon, equals log, and then to scoot left and right, it goes in with the x, and left and right's the opposite way. So there would be your equation, and then your description would be left 1. So you would need both of those answers in there. Bless you. Alright, when you get number 9 fixed up, go to your graphing calculator and graph number 10. Graph y equals e to the x.
How you do it?
Second, ln. Get something looks similar to what I drew there? Just a rough, ugly picture? Similar? Now compare that to the picture, and Dalton sees a reflection. Does it look like they just flip-flopped it? So which axis did they reflect it over?
Y.
So that's one of our answers, reflected over the y-axis. Now how do we write an equation when something gets reflected over the y-axis? We've got to put a negative somewhere. No, that's my gut feeling, but it's not right. It's e to the negative x. And here's why, and this is crazy to say this. It reflected over the y-axis, but what that did was it moved the x values. So that's why the negative goes on the x. Okay, when you get that one done, graph number 11, y equals 1/2 to the x power.
Down 2.
Okay, I got my graph to look something like that. And Landon's right on how it compares to the other graph. The other graph is down here. So we just counted and saw the space there and saw that it just took it down 2 units. How do we show a down 2 on an equation?
To the left.
No.
No, to the
Purple would be out.
Just stuck on the end, -2. Very good. Now for number 12, when you get ready for it, you've already graphed e to the x on number 10. So remember what your e to the x on number 10 looked like. That's part of it. Okay, it does, if I'm comparing this to the picture, it does go down 3. So Carolyn and Dalton's got that. That's one of them. But I think it also went
left 2.
attaboy, Mr. Cobb, it also went left 2. Okay, so to write this, we're going to say g of x equals e to the x. Left and right goes with the x, so my x is an exponent. So up there with the exponent, I got to put left, so +2. And then the -3 will just be stuck on the end. I did pretty good at that. Yes. No, other way, other way. Down 3, left 2. He was digesting. Alright, 13 is just a yes or a no question, and we wrote something similar to that in our notes when we wrote change of base. If I had log base 6 of 13, that's the same as doing the log of the big number divided by the log of the base. So far the first two are the same, and if they can both be logs, they can also both be natural logs. So yes, those would all three be equal. The only way they wouldn't be is like on the second one here. Maybe if they put the 6 on top, the big number has to be on top. Okay? And by big number, I don't mean larger digit. I mean the one that's not a base. Does that make sense? Base number has to go on bottom. Base bottom. That's a good way to remember that. Alright, back page.
I was having
Wait,
trouble
did you put
with
yes on
16.
13?
Mhm.
Okay.
You're having trouble with what, Carolyn?
16.
Okay, we'll get to that one.
No, I think better do something.
Alright, so 14, I've got 2 to the 2x minus 1 is equal to 8. You could, I guess, write this in log form. Anybody do that?
Nope.
Good, because I didn't either, but I think you could. Since I had a 2 on the left, I rewrote 8 as a 2. Is that what everybody
Wait,
did?
I did.
Oh, you did log form? I just said that. You said no.
Well, I'm having the wrong thing.
Well, you could, and I think it should be right. So we'll check your answer and see if you get the same thing as us. The way I did it is since this had a 2, I rewrote 8 as a 2 because 8's the same as 2 cubed. So now
Did you
since
bring the things down?
now since bases are the same, the exponents have to be the same. So we just got a 2-step equation to solve. We're going to add our 1. So 2x is 4. And then divide by 2. And x is 2. So what you got doing it log way? Good.
Yeah, I did that way.
Good. Good job. And when on 16, Carrie Lynn, I'm going to do that on 16 also, the one you were confused on. Log 2 of 8 is 3.
Yeah, 13.
Yeah. So you ended up with that same equation there when you did it that way. Alright, 15. 15, I'm going to rewrite that in exponential form. So I've got log base 2 of 7x plus 9 is equal to 1. So in exponential form, like Stephen said, that would be 2 to the first is equal to 7x plus 9. 2 to the first is just 2. So 2-step middle school equation, subtract your 9. 2 minus 9 is negative 7. And then divide by 7. So x is negative 1.
On the first one, where did you get 3? You said 2x minus 1.
Since this one had a 2, I wanted 8 to be a 2 also. And 8's the same as 2 times 2 times 2, 2 to the third. Now, you didn't have to do it that way. You could have rewrote it as a log equation. So you could, it would look like this if you did that one in log base 2 of 8 is equal to 2x minus 1. Then you would just type that in your calculator and you would have an equation to solve after that.
If you flip a fraction, what it becomes?
Yes. Alright, so on 16 now, I was telling Carrie Lynn I did that similar to the way I did 14, but like Stephen just pointed out, it's got a fraction that we need to flip, so we're going to have to account for that. We've got 9 to the x equals 1/3 to the 2x minus 4. So if I'm doing this like I did 16, and I can't just put this one in log form because it's got 2 exponents. So I have to do it that way. I'm looking at 9 and 3, and I'm knowing I can rewrite those with the 3. So 9 is the same as 3 squared, right? And then there was already an x up there, so I keep that x up there. The 1/3, go ahead.
Okay, never
The
mind.
1/3's got the 3, so I don't want a power other than 1, but I need to flip it. To flip a fraction, it's got to be a negative power. So I got a -1, and then there's already a 2x minus 4 up there. So now we got 3 and 3. So just set those equal to each other. 2x, I'm going to go ahead and distribute that -1 over there. -2x plus 4. I added 2x to both sides. Well, what else would you do?
It's 4x.
So you got 4x equals 4. Then divide by 4. You got x is 1.
I didn't bring down the
Okay, I missed it.
Alright, 17, Stephen, is what you wanted the bell ringer to be like.
What is it?
We've got natural log of 2x plus 5 is equal to natural log of 3x minus 3. So this one's really a pretty simple one because you got natural log on both sides. Natural log equals natural log. So that means 2x plus 5 has to equal 3x minus 3. So those natural logs just kind of cancel out, and we got 2x plus 5 equals 3x minus 3. So you got 4 places there that you could start solving this equation at. It doesn't matter which one. Okay, Stephen would add 3. So that gives you 2x plus 8 equals 3x. Now he doesn't have a choice. He would have to subtract the 2x. So that just gives you 8 equals 1x.
I don't know why I couldn't figure out how to do 16 Friday, but
Just one of those days.
it dawned on me as soon as we got through.
I liked all 3 of these word problems. They were all pretty fun to look through. On number 18, the number of new chainsaws sold T years after the introduction of a new model is given by the function y equals 2300 times the natural log of 8t plus 3. How many chainsaws will be sold 5 years after the new model? And then you got to round in the nearest whole number because you're not going to sell a part of a chainsaw. We're selling the whole chainsaw. So 5 years would be our T, so we put a T in for the 5. Now if I'm putting, I said that backwards. If I'm putting a 5 in there, because that's what the question asked for, 5 years, 8 times 5 is 40, plus 3 is 43. So all I got to figure out is 2300 times the natural log of 43. So that's a straight up calculator problem. I get scared when I'm using the calculator, so I did the natural log of 43 first, and then I times that by 2300. You end up getting an ugly decimal, but we're rounding to the nearest whole chainsaw, and I got
600.
8,651 chainsaws is correct. It's a lot of chainsaws.
She said ugly decimal, and I was like, oh, we got this wrong.
It was like, no, I got this right.
I had 86.
Anybody need help getting that in your calculator?
I did not mess up.
Alright, we got a 3-parter on number 19 with the birds. This is one some people told me they had trouble on. An endangered species of birds has a population that's modeled by A equals 1600 times e to the kt power, where A in hundreds represents the current population of the birds T years from now. Okay, part A is the easiest one because it says that the scientists figured out what the K value is. It's negative 0.23. So it wants us to write the function. So all we got to do for part A is take the k out and put the negative 0.23 in. So we're going to say a equals 1600 times e to the negative 0.23t. Why negative 0.23? That's what the scientists figured out it was. So that's your first answer. Okay, our second one, part B, says tell whether or not that's a growth or a decay. It's a decay. Very good, Carolyn. We got a negative power. Okay. Part C says what's the population 6 years from now?
40 birds.
Where would I put the 6 years in this one?
That is
In the
exact-
T.
In the T. So I'm on my calculator now, and I got 1600 times e to the negative 0.23 times 6 power. I did e to the negative 0.23 times 6 and got an answer, and then multiplied it by 1600 after that. Now remember, this is birds, so again, we don't want a partial bird. So let's round this to the nearest whole bird. How many whole birds would we have? 403.
But this is zeros, 403 birds.
That thing was right there.
It was a miss-up. And I didn't have an eraser.
All right, number 20 has to deal with the last thing that we've learned. Shh. We got some ordered pair, and it's going to ask us to write an equation for it. It says the table shows the number of R rabbits in a particular forest T years after a forest fire. Write an exponential model. That means an equation, so we've got to write an equation in y equals ab to the x. Now, the reason a lot of people will think they don't know how to do this one is because they gave you 1, 2, 3, 4, 5, 6 ordered pair. In class, I only ever gave you 2. Big whoop, pick 2. Okay, so the ones I'm going to use the ones I used on my paper. I chose 160 and 4 1620. Those are the 2 that I used. Okay, so we plug those in for the y and the x, and we start off. We've got 60 equals ab to the first, and then I'll have 1620 equals ab to the fourth. Okay, we solve our first equation for a. It's being multiplied by b to the first, so we just divide by b to the first, and a would equal 60 divided by b. B to the first is the same as b. Okay, take what a is, substitute it in there. 1620 equals 60 divided by b times b to the fourth. B to the fourth over b reduces to b to the third. So we got 1620 equals 60 b to the third. So we're trying to solve that for b now. My b is being multiplied by 60. So we're dividing by 60. So figure out what 1620 divided by 60 is. Everybody got it? 27, good job. Equals b cubed. Now this is very rare that when you write an equation it comes out as a whole number, but this one does. Because to undo a cube, you cube root. The cube root of 27 is 3. So we got a b of 3. Now we take that back over here and plug it in to figure our a out. 60 divided by 3 means our a is 20. So for our first answer on number 20, our equation is y equals our a, which is 20, times our b, which is 3, to the x. So there's your first answer on number 20. Now, the second blank, it says write an exponential model. Check, we did. To find how many years it will take for the rabbit population to surpass 20,000. Okay, so 20,000 will be our total here, our total number of rabbits. So we're going to say 20,000 equals 20 times 3 to the x. What do you think you'd do first to start solving that? No. Get rid of the 20. That's your extra junk there. So we're going to divide both sides by 20. What does that get us? Equals 3 to the x. This is exponential form. B to the e equals n, right? It's just flip-flop, so rewrite it in log form. Log base 3 of 1,000 is equal to x.
6.21.
And that was years. So after after a little more than 6 years, there would be 20,000 rabbits in the forest.
I wrote it up and got 7 years.
That would be fine.
Okay.
We talked about doing the whole chainsaw, and then all of a sudden you got a part of a year, so that would be fine. I think that's what you said too, one of y'all, yeah. All right, what do you think?
Should be.
I
Ah.
actually got them all right.
Good. I didn't think it was very hard at all, and then I was asking every class yesterday what they thought, and all of them said pretty good except for third period. I just don't know about that third period group. All right, you got notes from me?